Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 28. We're continuing our investigation of trigonometry, and now we're going to talk about the addition, subtraction, sine identities. So in the previous episode, we looked at the addition, subtraction identities for cosine. And to recall, we said that cosine of alpha plus or minus beta is equal to cosine alpha, cosine beta, minus plus sine alpha, sine beta. We are actually going to use the cosine identity here to derive the sine one. So if we start with the question, what is sine of alpha plus beta, we can use the cofunction identity. So the cofunction identity said that sine of x is the same thing as cosine of pi over 2 minus x. So if we use this identity, then this is the same thing as cosine of pi over 2 minus the quantity of alpha plus beta. And we can rewrite this as cosine of pi over 2 minus alpha. We think of this as one quantity minus beta. So what we did was distribute that negative. And notice now we have cosine of some quantity minus another quantity, and we can use our subtraction identity. So this is the same thing as cosine of pi over 2 minus alpha, cosine of beta, plus sine of pi over 2 minus alpha times sine of beta. All right. Now, if we think about this for a moment, right? At first this might look scary, right? Because we have cosine of a pi over 2 minus alpha and a sine of the same quantity. However, these are both cofunction identities, right? In fact, this we already mentioned what it was, and now let's mention what this here is, right? So the cofunction identity for cosine says that actually no, I had that backwards. Oops. So this here, this cosine of pi over 2 minus alpha, we already stated what that was, because that's just actually going to be sine alpha using our cofunction identity. So now we need to figure out what this is. And this is actually our other, or one of the other cofunction identities. So cosine x is equal to sine of pi over 2 minus alpha. So we can use this cofunction identity, and that'll take care of the sine of pi over 2 minus alpha. Oh, I put alpha, that needs to be an x right there. There we go. Beautiful. So using our two cofunction identities, this actually becomes sine alpha cosine beta plus cosine alpha sine beta. That's the addition identity. Cool. Now, to discover the subtraction identity, we can make a substitution, right? So if we say sine of alpha plus m is equal to, so just using what we just proved, this is sine alpha cosine m plus cosine alpha sine m. And we can make a variable substitution where if negative beta is equal to m, then we get sine of alpha minus beta is equal to sine alpha cosine of negative beta plus cosine alpha times sine of negative beta. Now, we can use the even-odd properties of sine and cosine, and note that cosine of negative x is equal to cosine x, because cosine is an even function, and sine of negative x is equal to negative sine x. So simplifying this, then we get sine alpha cosine beta minus cosine alpha sine beta. So we get the minus sign because we have that sign of negative beta here, and so that negative is moving out front according to that odd property. So to summarize then, sine of alpha plus or minus beta is equal to sine alpha cosine beta plus or minus cosine alpha sine beta. So the way you want to read this notation is when you have two angles being added inside a cosine, or I mean within the sine, then you have to use the plus sign. And when it is the case that you have the minus, then you use the minus over here on the right as well. I like this notation because it kind of condenses it down. There's a lot less writing. It just looks a little weird at first if you're not used to it, but it is very useful. And with that, this concludes this episode on our sine. So we were just wanting to derive what the addition subtraction identities are for sine, and we have done that. So thank you for watching this video. If you've been enjoying our content, please subscribe and consider supporting us on Patreon. Thank you for joining our math party, and I will see you next time.